Hello my dear students, let us take one more example on Thyssen polygon method. A catchment is idealized as a 25 by 25 kilometer square. It has 5 rain gauges, one at each corner and one at the center. During a month, the precipitation at G1 rain gauge station 1 is equal to 300 mm and G2, that is rain gauge station 2 to 85 mm, and G3 rain gauge station 3 to 72 mm, G4 rain gauge station 4 to 90 mm, and G5 is 288 mm. Evaluate the average precipitation over the catchment during this month by Thyssen polygon method and compare it with the arithmetic mean method. So what you have to do, first you have to calculate average precipitation using Thyssen polygon method, and then you have to find it with the arithmetic mean method and compare. Okay, so this is the given catchment, okay, of a square area, 25 kilometer by 25 kilometer, and these are the rain gauge stations G1, G2, G3, G4, 5 rain gauge stations, so 4 at the corner and 1 at the center. Okay, precipitation is given for each rain gauge stations. Let us first find the area of each rain gauge stations. Right, so first this is the rain gauge stations A G1. So G1 means the area is this area now. What is that area? A into G1 into B. That is the area of G1. Next, area of G2 is B, G2 and C. Area of G3 is C, G3, D. And area of G4 is D, G4A, and area of G5, this is the area, surrounding area is this, okay, that is nothing but area of A, B, C and D, that is the area of G5. So how to calculate the area of each rain gauge stations? See, we have this area, the total outside area. The total area is given, that is 25 by 25. So this is 25 kilometer, this is 25 kilometer. So we know this is A to G1, that distance is 12.5 and B to G1 is 12.5. You can find what is AB. So what is that? AB square is equal to A G1 square plus B G1 square. A G1, that is nothing but 12.5, that is nothing but 12.5, and G1 to B also 12.5. So AB square is equal to 12.5 plus 12.5 square. Okay, AG1 square plus BG1 square, that is equal to AB square. So AB is equal to square root of that. So we will get AB is equal to 17.68 kilometers. After that, what we have to do? We have to calculate the area of each rain gauge stations. So area of G1, G2, G3, G4 means this area AG1. A G1B, and this is B G2C and C G3D and D G4A. These are all same. Okay, so how you can calculate? The total area is G1, G2, G3, G4 is equal to 25 into 25, that is 625 kilometers square. So then inside area ABCD, that is we calculated what is AB. AB is 17.68. So BC also 17.68. CD also 17.68. AD also 17.68. So inside area ABCD is equal to 17.68 into 17.68, that is 312.5 kilometers square. Now area of G1 and area of G2, area area of G4 is equal to the total area, that is 625, minus inside area, that is 312.5, divided by 4, because there are 4 areas, 1, 2, 3, 4. So that gives the area of each G1, G2, G3 and G4. Okay. So I hope all of you understood. So what you have to do, you have to consider the total area minus deduct this area. So you will get these areas, this area, this and this. I want only one area separately I want. So AG1B is divided by, all the 625 minus 312.5 divided by 4. That is equal to 78.25 kilometer square. Now we know all the areas, so we can calculate what is the average precipitation. That is equal to what? P1A1 plus P2A2 plus P3A3 plus P4A4 plus P5A5 divided by total area. What is P1? P1 is equal to 300 into A1. A1 is nothing but area of G1, that is equal to 78.25 plus P2 is 285 into same area 78.125 and 272. Next P3 272, G3 that is equal to again 78.25 plus G4 290 into 78.125 plus G5, that is 288. G5 is this, so that area is 312.5 into 312.5 divided by total area. Total area means A1 plus A2 plus A3 plus A4 plus A5 or G1 plus G2, G3, G4, G5. That is nothing but 25 into 25, that is 625. So simplify this, you will get P average, that is equal to 287.375 mm. Here all the rainfall units are in mm, so the final answer also in mm. I hope all of you understood. Very simple. First you have to calculate the area of each rain gauge stations. For that, first find the side, any one side, AB or BC, CD or AD. Then find the total area, deduct this inside area, so you will get the area of this divided by 4, that gives the area of each rain gauge station. All rain gauge stations G1, G2, G3, G4 are equal, but G5 is different, that is area of this side. So that you have to multiply here, so you will get P is equal to this. Now you have to compare it with the arithmetic mean method. What is arithmetic mean method? The formula is P1 plus P2 plus P3 plus P4 till Pn divided by n. So what is that? P1 is equal to 300 plus 285 plus 272 plus 290 plus 288. Total number of rain gauge stations are 5. So divided by 5, that gives P is equal to 287 mm. So almost both the methods gives the same answer. Okay. So like this, you can find our rainfall using Thiessen polygon method as well as arithmetic mean method. I hope all of you understood. Let us take one more example on ISO heights. So the ISO heights due to a storm in a catchment were drawn, and the area of the catchment bounded by ISO heights were tabulated as below. Estimate the mean precipitation due to the storm. So these are the given data. ISO heights are given. It is a line, okay, a contour line like that. So it is 14 to 12, and then area is 30 kilometers square. Then 12 to 10. 12 to 10, then 140, and 10 to 8, 80, 8 to 6, 180, 6 to 4, 20. How to calculate this? First, you can do this table and write the values. Okay. First, ISO heights are given. That is 14 to 12, 12 to 10, 10 to 8, 8 to 6, 6 to 4. Then average value of P we have to calculate, because ISO height method, what it says, it is nothing but the average value of AI into PI divided by AI. So that is the formula. So AI and PI means what is that, how to calculate? So that will calculate in the second column. So average value of P means PI plus 1. What is that? 14, that is PI. PI plus 1 is 12. So 14 plus 12 divided by 2, that is 13. 14 plus 22 is 36. So 36 divided by 2, that is uh, sorry, 26. 14 plus 12, 26 divided by 2, 13. Okay, similarly next is 12 and 10. So next value is similarly PI plus 1 divided by 2, that is 12 plus 10 divided by 2. So that is 22 divided by 2 is 11. Then 10 plus 8, 18 divided by 2, 9. 8 plus 6, 14. 14 divided by 2 is 7. 6 plus 4, 10 divided by 2, that is 5. After that, area, this is given in the problem only, that is write that is AI. What we want, AI into PI. AI is this one, PI is this one. So multiply that. Column 2 into 3. That is 13 into 30. That is 390. And 11 into 140, 1540. 9 into 80, 720. 7 into 180, 1260. 5 into 20, 100. So take the sum of this. So that is, when you add all this, you will get 450.0, and when you add here, you get 4010.0. So the average precipitation, that is equal to AIPI divided by AI. So that is 8.91 centimeter. Or you can use the direct formula. This is the formula. P average, that is summation of A into P1 plus P2 divided by 2 divided by sigma A. Or you can write in this way also, PI instead of P1 you can use PI plus PI plus 1 divided by 2. Anything you can use. If you use this, you can directly write here P1, that is 30 here, into P1 plus P2 divided by 2. So 30 into 13 plus next is 140 here, 30 into 13 plus 40, 140, AI is 140 here according to this. A is 140 and P1 plus P2 divided by 2 is 11. Next case is 80 and into 9. 180 into 7, 20 into 5 divided by total area, that is 450. So you will get 8.91 centimeter. Any method you can use. Either you can use this make a table and write all the values. This is simple. Or directly you can use the formula, that is sigma A into P1 plus P2 divided by 2 into divided by summation of A. It's the same thing here. Then also you can calculate. Okay, so like this you can find the precipitation using isohydral method. I hope all of you understood. Thank you.